What if we told you you could give your serverless application a serverless or a superhero cape and send it off to superhero school? Myself and Julian are going to talk to you today about how you can give your serverless applications that spider bite. But instead of them going around shooting out webs, they'll be able to take actions on your behalf whilst integrated with AI tools. My name is Ronan Prenty, and I'm a Principal Solutions Architect based out of AWS in Dublin. I started there 9 years ago in the graduate program, and for the last 9 years, I've been working pretty much solely on serverless and helping some of Europe's biggest AWS customers build customer-facing apps. This whole MCP and AI with serverless topic is one of the things that has excited me the most over the last 9 years, and I'm really excited to get into it with my colleague Julian today.
Awesome. Ronan, have you been doing MCP for 9 years? That would be impressive.
I wish.
It's so good to be back here. What a lovely venue. I just want to say hello, and to the AWS people at the booth at the back, our friendly colleagues. They would love to talk to you about AWS, about serverless, about other kind of things. I also want to pick out, we've got two people from Dublin. We've got Jonathan, can you give a wave? And Naman, can you give a wave? Jonathan's actually a product manager for Lambda based in Dublin. He works on the Lambda runtimes. He has a question for everybody here today. If you had a magic wand or you were king or queen for the day, what would you change about Lambda? What would you improve? So Jonathan is desperate for information, so he'd love to chat to you, or you can talk to me and link about it. But I'm Julian, as Ronan said. I'm a developer advocate. I've been working at AWS for 5 and a bit years, doing pretty much serverless all that time, and it's a pleasure to be part of the Serverless Days Belfast community.
So what does your AI application know? Well, it turns out it knows quite a lot. If we think about these large language models, they're trained on a ton of data, and they have knowledge we can ask them questions for. In my case, in preparation for this, I asked Claude, I didn't write this myself, to write a poem about Belfast and serverless. I'll read it out for you. Grey Harbour City, shipyard standing tall, functions floating free, no servers at all. Lagan meets the sea, code meets the cloud, two worlds transforming quietly loud. So you can see... I didn't write it myself. So you can see these models know quite a lot of stuff. They're quite powerful. You ask them text-based questions, they give you answers in return. But they have their limitations, right? You can see that in preparation for the talk, I asked the model, what is the weather going to be like for in Belfast on the 15th of May? Praying we got weather like this, which is incredible. And you can see in the response, I don't have the capability to check the weather forecast. So there's some things that our models actually can't do typically. It's worth noting that with tools like Amazon Q out of the box, they are starting to get more functionality. So with Amazon Q CLI, there's a Use AWS tool, which allows you to talk to your AWS resources and actually interact with them from the command line. So like I said, they know what they know. Our LLMs know what they know, but they don't know what they don't know. And we can do certain things to help with that. So in terms of customizing your LLM and like making it more specific to your data, we'll go from the bottom to top in terms of complexity and cost. You can train your own LLM and make that available on your own data. It's very complex and very costly. You can take an existing LLM and tune it with your data by fine-tuning it. You can use retrieval augmented generation, which is where we can integrate with different data sources or knowledge bases to make our models more useful, right? Give them more context about the information we're working with. And then we have prompt engineering, which is essentially we can take data, inject it into our prompts, and make it more useful that way. So can we add more context into the prompts to make them smarter? Absolutely. Can we make them autonomous too? Absolutely. So a little brief bit on agentic AI and autonomous agentic AI. If we look at the agent in the center, that's not just responding to text-based questions and giving answers. It's actually doing a lot more. With agents, we can integrate with things like memory to be aware of the questions that we asked and data it has seen before. We can integrate agents with tools to give them a certain level of autonomy to integrate with different resources. And we can set goals for our agents, so tell it what we want to do so that it can work with those resources to achieve those goals. So it can use the tools to integrate with your environments and take action on those environments. And you'll see examples of that later on. And what ties all this together is the observation aspect. So as your agent is doing work, it's observing what it's got back from the environment, and it's taking action to make sure that it achieves the goal that you want. So if we look at how you are communicating with different tools and resources, on the left-hand side, you can see that the agentic AI vendors are typically responsible for implementing their integrations with external tools, and the external tools rely heavily on the agentic AI vendors. This is where MCP comes in, and something that I'm really excited about. You know, it's a really new topic. By the time people are watching this video on YouTube, everything I say will probably be outdated, right? So what is MCP? MCP is Model Context Protocol, and a nice way to think of it is like the API for generative AI. One really nice anecdote I heard about MCP when I was getting up to speed on it was from the Anthropic website, where they talk about how it's like a USB-C port for your LLMs and your AI applications. Think of your USB-C port. It makes connecting accessories and things like that kind of like a universal standard, right? And we're looking at MCP in the same regard. So like I said, it's an open standard by Anthropic. It helps solve the complexity of integrating between tools and AI vendors. We have a client-server protocol. It makes it really slick and easy to connect to data and external tools that you may want to make your AI application more useful. So with MCP, you can see on the left and the right-hand side now, with the introduction of MCP, it's a standardized protocol which allows us to integrate with those different tools with way less tight coupling or dependencies on each other. In terms of the MCP servers that you can take off the shelf and use, there's tons of them. There's more and more being released all the time. I mean, there's ones for integrating with AWS Bedrock knowledge bases, AWS documentation, Stripe, Postgres. The list is growing more and more by the day. Over to Julian for the building blocks.
Cheers, thanks, Ronan. So I'm going to go through the building blocks, but as Ronan says, this can be out of date really soon. The protocols are changing, the spec is changing, and part of this talk is also to give you a bit of a sort of future look into maybe what agents can do and some cool things we can do with Gen AI. We're also figuring this out and working this out ourselves, so things may change. You may find your own things that are interesting and your own things to explore. So this is also a rallying cry to find some cool use cases that you can do with your Gen AI stuff. So yeah, so what is sort of MCP made up of? So as Ronan showed, we've got this MCP host, and this is basically your laptop or your workstation or something, and this is going to be that's running a program. Now, it could be Claude desktop, so if you're using Anthropic, Claude is their sort of native AI client, but it can be Amazon Q, there's one in IDE and Amazon Q CLI, so that's obviously one from AWS and Amazon rebuilding, but things like Cursor. Has anybody used Claude so far, Claude desktop? Got a smattering of hands. Has anybody used Amazon Q? A smattering of hands. Anybody used Cursor for IDE stuff? Yes, excellent. Windsurf, that's another one as well. So we've got a smattering of hands that are people already using these IDE tools or command line tools, and MCP is something that can just plug into them. Can be also used via an SDK. So within the tool, there is an MCP client, and this is just going to be like a client-server architecture that is going to call an MCP server, and the MCP server has got some intelligence of tools that it's going to run, and that tool is then going to get some information, send some information, do some stuff, and that stuff may be in a database, it may be in a data store, and maybe need to talk to another API, maybe need to talk something publicly, maybe talk to something privately, any kind of thing that's going to be. And those tools the servers can be local or remote. So you could have an MCP server that is just a script literally that runs on your workstation that gets some data that is running locally and can provide it to your LLM, or it can be remote. So you could have a local MCP server, something in your laptop connects to the weather API, for example, to get Belfast weather for the day, and that would then give you up-to-date information. And of course, your MCP servers can be in the cloud, can be anywhere, can be remote, and so you can have remote MCP servers also talking to remote services. So sort of different ways and different architectures that you can put these together. Between local and remote, there's sort of two different transport protocols. The initial transport protocol was standard I/O, so this is for everything local. This is just using I/O ports based on your local workstation, and you connect your tool locally. Very simple for connecting to local MCP servers. MCP is super new, only came out last year, and it was earlier this year that they then decided, you know what, we actually need to have a remote version as well. We can't rely on everything being locally. And so there were a protocol that came out which was called Streamable HTTP, and the initial iteration had an SSE, which was called server-side events, and that was a way that you could have a remote HTTP server, which could then maintain a stateful connection based on your client and send updates to that client. People were always like, okay, oh, that's cool, but I don't always have to have a stateless connection. I mean, specifically in the serverless world, you're like, oh, we don't want to deal with state. That's something we've given, something we solved 10 years ago. And so the SSE has actually evolved that you can also have stateless HTTP connections, which is perfect for running in a serverless world. So the three different things that MCP servers support are these resources, tools, and prompts. And so resources are things like database records or file things or some API responses, sort of static data. If you would think of doing something that you would get something, that's what a resource would be. A tool is then something that you can do. So this could be updating a database, this could be retrieving something from a search or aggregating something, sending a message, updating database records. So this is sort of the action that a tool can actually do. And then there's a prompt. We've heard about prompt engineering earlier today. The whole thing about MCP is giving more information to your models. So why not just have templates for those prompts, things how you can do transcriptions or summaries or some guidelines that your model needs to use to say, for example, I want to output this as JSON. So because this is fast moving, not all clients support all of these kind of things. Everybody supports tools. Some don't support prompts. Some do and don't support resources. So it's an ever-changing world, which just makes it more fun. But this is what the MCP spec has in mind for the future. When you're building MCP servers, you don't have to roll your own server, and we're at serverless days, so I hope I'm not freaking out too many people when we're talking about servers, but conceptually you do sort of import a server into your code. Lots of different libraries, all the different languages support these already. Fast MCP is a very popular one for Python, and then for instance, even if you're using Java, there's a Spring AI starter MCP server for Java. Import this into this code, and you can build an MCP server pretty easily. It's actually not got a lot of code in it. When on your client, you've got some configuration over here. So you can actually see I have the Claude desktop configuration and Amazon Q for the MCP. And actually, the configuration is syntactically identical. You could move these files between each other. The left-hand side, you can see that this is the AWS documentation MCP server. Ronan's going to show that shortly. It's using UVX, which is a Python sort of packaging manager, way cooler than using pip and all those kind of things. And what is this doing? It runs UVX, that sort of name, and it's got some parameters, and that's literally all it's doing. So that's going to pull down that little bit of code from AWS Labs or AWS Stack, long thing, pull that down and run that locally. On the right-hand side, you've got a Node version. So if you've got an NPX, you need to have NPX or Node and NPX running locally. What's that going to do? It's going to, this is one for a file system one. It's going to pull that down, and it's got some parameters to say access to desktop and downloads as well. So this is the configuration file. So you can see there's very little that actually needs to happen on the client. The other option as well is you can use Docker. So lots of MCP servers are released as Docker containers. So again, you then don't need to have Python or Node or Java, whatever, installed locally. The Docker container can pull itself down, install everything it needs, and up it goes. So when you define tools, this is where the actual simple but clever part of MCP is. So an MCP tool has a name, and this is a very descriptive name, and it obviously needs to be unique. And it has a description. And this is what, and I'm going to go through the workflow shortly, but this is what gives intelligence to the LLM. The LLM just literally looks at the name and then looks at the description. So for this example, the name is delete the files. The LLM goes, I've got a tool that can delete files with a description of delete a file from the file system. So this is a very simple example, but you can imagine for AWS documentation, for example, read or search or get information from the AWS documentation, and then a description of the kind of things it can do, the kind of things it can't do, when it should be used, when it shouldn't be used, and it's just a text-based instruction to the LLM to do it. An input schema, so if you're calling an API, for example, or deleting a file, you'll need a file path. So these are the kind of things that is a structured way to be able to call your tool with what it needs. Again, it's just written in a schema over here. And then annotation, this is sort of some kind of hints. So it's not used in many tools, but in this example, for example, it's delete file, so you can actually set destructive hint, for example, to true. So it knows that, well, maybe you want your tool to ask you again if you really want to delete something or have some kind of protection against this. So there are some predefined annotations which you can use, which can make this a little bit safer, or at least the LLM understand the intentions of this tool. So just to zap quickly through the workflow, or you've got to, when you have a prompt and you then ask your AI assistant. So this can be Claude, it can be Klein, it can be Cursor, it can be Amazon Q, and this is the sort of text field you're going to type in and say, I want to do something. So what your tool is going to do is, it is obviously connected to some LLM. Maybe it's using Bedrock behind the scenes, maybe it's using Anthropic or Claude, whatever, you may not even know, but basically it's going to call the LLM. And it's going to send to the LLM the prompt you need and also the list of registered tools that the AI assistant has registered, with those names and the description. So the LLM is going to look at your prompt and say, aha, I know that I've got these 5, 10 different tools. This tool may be useful for your task, or this tool, or these tools may be useful for your task. I suggest you use those tools. If it doesn't have any tools it's going to use, it's just going to respond with a normal response. So this is a sort of clever thing that the LLM is going to use natural language, work out what the tools it's going to do, and then it's got that JSON schema and goes, well, I'm going to call the tool with that file path, with the thing you want to search in the documentation, whatever. Calls the tool then asks the data source or the API or some other cloud service, gets the information, sends it back to the agent, which goes sort of via the LLM, and the LLM will get all the information and wrap it up in a nice pretty bow with some something and send it back as a response, and there you've got it. So you've sort of got this flow. Now, the interesting thing to think about this is, first of all, why are the tools important? As Ronan says, the LLM doesn't know what it doesn't know. So this is to get up-to-date information. So you want to get the weather today, the up-to-date stock price, customer details, all things that you're not going to put in your LLM. But there's also a cost component to this. We know that GenAI is not cheap. And so if you're going to have to put a whole bunch of stuff in GenAI and get GenAI to do more, well, it's going to be slow, it's going to be complicated. So you can actually have a far cheaper model for your LLM, because what is the model doing? All it is here's my prompt and here's my list of tools. You don't need to do anything clever. You don't need to write a poem. You don't need to do anything like this. All you've got to do is look at my prompt, look at the tools I've got, and tell me what I need to do. So that can be fairly cheap. Sometimes when you've got an agentic system that talks to multiple LLMs, when the response all comes back, it may then say, here's the original response, the response from the tool, let me now craft a report, or let me do a graph, or this kind of thing, and maybe it'll use another model for the final output, but the initial output can be sort of a cheap way to use GenAI. So, MCP for AWS, on to you.
Yes, I'm going to take you through a couple of demos now of using MCPs for AWS, on AWS, etc. First example I'm going to run through is let's look for some up-to-date AWS documentation. I'm running in the Claude desktop client here, and you can see I'm asking it a question about Lambda runtimes, right? So what are the runtime versions currently supported by AWS Lambda? We'll see here that basically Claude comes back. Take note of the very first paragraph there, that there's a knowledge cutoff in October 2024. So that's an important point to note, what we've talked about already. It doesn't know what it doesn't know. Things have changed since then, right? I'm going into my MCP server file, like Julian talked about. I'm enabling the AWS documentation server. You can see exactly like Julian said, this is how I'm pointing to it to make sure I invoke it. I'm refreshing my Claude desktop, so I've quit it. I'm reopening it again. And you can see here in the search and tools, I've now got this available at the bottom, the AWS documentation, where I can read, search, and recommend AWS documentation. So I'll ask pretty much the same question. What runtimes are available on AWS Lambda? And you'll see here it gives a bit of thought, and now we're starting to get our response. So you can see now it's asking, is it okay to use the external integration that I've set up? So I can choose to allow it once, or I can choose to basically trust it for the whole time that my session is available. So you can see now it's actually starting to search the documentation based off my question. It asked if I wanted to use the search, if it was okay to use the search. Then it asked if I was okay to use the read documentation. So you can see, obviously, it has searched AWS documentation about the runtimes, and now it's starting to do that kind of autonomous part that we talked about, right? It's observing the responses that it's got, and it's continuing to use the tools that it needs to achieve the goal that I've asked it, right? So I just want to know what are the runtimes. And you can see here it's doing a lot of work on my behalf. So we're still reading documentation here. A lot of reading documentation going on.
The thing is, it does also remember this. So if you do run it once, the next time it's going to be much quicker.
Yeah.
And yeah, we are laboring the point of showing multiple tools over here as well.
I suppose when I started to run this tool, maybe Claude had a slower day that day. So you can see now it's actually got the information about the managed runtimes. Now it's starting to get the on OS-only runtimes. So we're starting to wrap up here, and you'll see basically what the point of this demo is to show you the most up-to-date documentation. So the model didn't really know. You'll see now the versions offered. So what we saw before was Node.js 20, for example. We can see actually the most recent version is 22 and all the other associated runtimes with that. Another demo that we saw, like one of our colleagues, Anton, who's a specialist serverless SA based out in the US, made a really powerful GitHub repo with some samples inside. And this demo is taken from that repo. We'll provide a link at the end of it. What I'm asking in this case is, well, actually, what Lambda functions are in my AWS account that are running outdated runtimes? So by default, Claude is basically going away and telling me some scripts that are building me a script that I can copy, run it locally with some AWS credentials that will discover the runtimes, which ones are out of date, and recommend which functions I need to update. But that's not really what I want, right? We talked earlier, you want to make your tools more useful. You want maybe it to do something on your behalf. So Anton built this great demo where you're essentially running the MCP server locally using Node. So I'm using Node. I'm pointing it at that file. I'm going to give my Claude desktop a refresh. And we're back in business. So you can see now I'm going to look at my tools section. You can see I now have this Lambda ops tool. I have get runtimes info, list function, get function, invoke function, update runtime. So that's all code that he has written in the MCP server. So now let's have a look. What's inside my account that's updated? So I'm going to just allow the get runtimes info tool. So that's going to retrieve all the information about Lambda runtimes and start to compare that against the AWS Lambda functions in my account. So what we're doing right now is we're just listing all the functions that are available. And now we're actually comparing them to what's deprecated and what's not. So it tells us more about what's already deprecated, what's approaching deprecation, and what functions are in my account that are running kind of outdated runtimes. You can see there's a couple of functions running Python 3.9, tells us when it's going to be deprecated. And I'm asking it, hey, would you mind upgrading this function? Upgrade the first one and test it. Of course, you've got to say please at the end too. So you can see now it's just running through like which runtime it's going to upgrade it to. I'm going to allow that action. So we're retrieving the function. We're performing the update runtime action that we talked about earlier. You can see it's been updated from Python 3.9 to 3.12. And we actually want to invoke it now to see what's happened, right? So you can see that the function was successfully updated, but the invocation resulted in an error, right? So the error that the model got back was that it was missing a parameter. What it's actually going to do is it's going to generate a new event object to send in the invocation, and it corrected it by itself, right? So it's invoking it with like a valid event object. And you can see it's invoked, it's executed successfully, it's upgraded the runtime all through that Claude desktop client, which I found to be pretty cool myself. So in this case, I basically just say, thank you very much. Can you please revert that change? It knows already what the expected event object looks like. It reverts the change, tests it with that event object. So this is like the context that it has from before, and everything works pretty well. So I'd encourage you, we'll include the QR code at the end where you can have a look at Anton's GitHub repo and some more repos. So you can see there, that's the final invoke after reverting the change. Let's wait for that to finish before we move on. I know you can see it's working properly, so I've reverted that change and it's working quite nicely. So we've talked about running MCP servers locally, kind of like to improve your operations, interacting with your serverless applications. Now let's talk about running MCPs in AWS that you can connect to from your clients. What we're really focusing on here is that bottom part. So Julian kind of took us through what the architecture looks like. We're talking about this bottom part where we're connecting to a remote server. Typically, customers are building, so Julian talked about persistent connections with SSE, where you want to manage state. Typically, customers are looking at things like ECS, Fargate for that. And for connectionless, or where you're not really looking to manage state, Lambda is a very nice tool to do that. Benefits of running them on AWS, so you're benefiting from the scalability and reliability, the security that you can kind of take off the shelf with things like API Gateway, custom authorizers, and things like that. You have observability out of the box with things like Lambda, right? So you can understand the traffic patterns, you've got logging in there, etc. Things to consider are your network latency. So can you tolerate network latency? There's a dependency there as well, right? So the MCP server is no longer running remotely. You're actually connecting out of your corporate network or whatever network it may be. Cost implications. So those tools, as we're invoking those tools all the time, of course, that costs money. And state management. So you want to think about if you want to manage state and how you're going to do that. So a very quick example of actually running a stateless MCP server on Lambda, where we're using Amazon API Gateway to expose the MCP functionality to our clients. And we're just running those servers that Julian talked about, taking those packages off the shelf, running them in Lambda to expose our server. So what really happens here is the MCP client sends off a request to that tool URL, like a discovery request. So what's the tool name? What's the description? What are the parameters that it expects? And then you can get stuck in from there. So in this example, you can see my Cloud Desktop config file. I have a MCP server called ping pong. And what all that does is when I type in ping, it invokes the remote tool and gives me back pong, right? It's important to note here that I'm using this external tool called MCP Remote. It's essentially like a local proxy with some of the tools or the clients now available for MCP. A lot of them don't support this remote connectivity out of the box. So that's not an AWS tool, and it's an external tool that I'm just using for the purpose of this demo. You can see my API Gateway URL there that I'm exposing my MCP server on. So what I'm doing there is I'm saying use NPX to run this MCP remote tool, and this is the URL that I want to use on that. I've refreshed Claude. I'm going to hit my ping endpoint. You can see this ping pong tool is available. It's enabled. It knows what tool to use. I'm going to always allow it. And what you'll see in the response here is essentially Pong, which gives you back the log that Lambda created to say this is the log stream, right, that I generated for this request. So just to prove that we can talk out to our external service sitting on Lambda, get a response back. So, this is a really nice way to think about like what kind of stuff could you build on Lambda behind API Gateway, exposing it to your MCP clients as an MCP, exposing it to your clients as an MCP server. When I was learning about MCP and experimenting with this, like one of the things I really enjoyed was this tool called MCP Inspector. Like, how do I actually visualize what's going on here? So there's a tool that you can get. It's called, sorry, let me kick that video off. MCP Inspector. you can just run it, point it at a local MCP server file, and it will spin up on your local host. You open that in your browser. You can see that's the URL you'll pop in. So this is it running. What you can see here is I'm basically inspecting on standard STDIO. You can inspect on SSE and streamable HTTP as well, right? So for streamable HTTP, I pop in my API gateway URL, I connect, and then I can list the tools. So I make that kind of like discovery requests that are available. And you can see my ping tool is there, and I can actually interact with it from that browser as well. You can see I get my Pong back and the log stream that Lambda created on my behalf. So other tools you can play with here as well is you've got this authentication parameters, and you can configure things like request timeout if you want to do that. But this was a really nice tool that I enjoyed using. It just really helped me wrap my head around like what's going on, how do you interact with it, etc. I think this is you.
So we showed how we can run remote MCP servers, but they don't also have to be remote. You can have local MCP servers, but talking to Lambda functions. And so a colleague of ours created this MCP to Lambda. And this is quite, I think, a clever, funky kind of tool. Because what it does is it allows you to run any Lambda function as an MCP to get the response from MCP without any code changes required. You're not actually running the MCP server. That's locally just connecting to a Lambda function. And so it acts as a bridge between your local MCP client and the bluish there to the Lambda function that's running in the cloud. And the cool thing is, it allows a model to run any Lambda function that is in your account. And there are two things this particularly clever tool does. One is MCP Lambda, you give it a prefix, or you give it a tag, or you give it something to say, go to my AWS account and pull all of the functions that start with, for example, MCP to Lambda. You could have that anything, or you do anything. Or pull any functions that have this tag. You could build it to do anything. So what that's going to do is that it's going to dynamically populate the tools with the available Lambda functions that you've got in your account. You only have to have one tool installed locally, which is going to be this MCP to Lambda. Connect to my account. You could have lots of people creating, deleting, doing all different things, building their tools. They are normal Lambda functions. They connect to your internal database. They connect to weather APIs, wherever, and they do kind of things. So this interesting story is you've also got the segregation of duty, that all your authentication is locally. You've got your AWS credentials to be able to list those Lambda functions and then to run those Lambda functions as tools. But the cool thing is your end user doesn't need access to that database or need that API key or need anything. Because that Lambda function is going to run privately, securely inside your own account and have access to that database or with an API key or that kind of thing. But the person actually running the tool doesn't need any access to that. So it's this nice sort of segregation of duties to do these kind of things. One of the Lambda functions, which I will show, is also the special Lambda function, where you're actually able to inject, in this example, Python code, but other people have done it for Node.js, where GenAI, what's GenAI good at building and running code, and so it can actually run that code for you, which is a sneak peek in what we're going to show. So here we go. I'm actually going to use Amazon Q. So this has also got MCP support. It's a command line tool that's going to run, and we'll show you how it's going to work. So this is my mcp.json, and you can see I'm MCP to Lambda, running UV, just going to run main.py. And main.py is a little script that's going to come up, enumerate all the functions in your account that start with MCP Lambda. So you can see here, I start QChat. It is then loading the MCP server. So what's that doing? Running that Python script, enumerating the Lambda functions in my account. MCP server is all up and running. I could have had many. So I can also then look at the tools that I currently have. And this is one of the cool things with Amazon Q, is that there are already a whole lot of built-in tools, including one called Use AWS, which has a whole lot of AWS functionality built in. And we're going to obviously add to that as time goes on. And it's then discovered these three different Lambda functions. Two of them are sort of getting customer information, and one about running this Python code. So as Ronan showed, there's a lot of authentication, and you keep having to do tools. So just for the sake of simplicity, we're going to do the bad thing and just trust all the tools. We trusted what it's going to do. Off you go. So we're going to do that, and then all the tools aren't going to keep bothering us to ask us whether we trust them, because of course we trust all the code that we've developed. Yes, no. So I'm going to say get the customer status for email john.doe@example.com. Go to the LLM, find out the information, and goes, oh, I'll help you get the info. I have some tools that can use this. I'm going to use MCP to Lambda. Name and description has told me I can use this. So here we go. I'm going to get the customer ID from email, because an email is provided. You provided the email, and here I've got the customer ID from my internal database behind the Lambda function. I then plug that in to get the customer info from the ID, and that is going to then use the other tool and get the customer information for the whole email address. So what has this done? This has taken two different tools. You've asked it one question. It said, I've got one tool I know that can get the customer ID from the email, and then it's going to come back and go, oh, but you've given me the ID. I want some more information. I've got another tool that can get the more customer information from the ID, and you can see here's all the information that has come back from the address. So this is where you can think of the agentic workflow that's going to happen. You've asked it one question, and it's come back with a whole bunch of tools that it's going to run. So you can imagine this example for a customer service rep, for example, when they're going to be able to get information, they can just do a natural language query. They don't need to know which database to connect to or have some sort of web UI tool that they need to do. They can ask kind of questions. And they could have asked, do I have any, maybe they could have asked general questions like, where's this from? California. Do I have any customers that are in California? And you could have another tool that could have done a search for anything with the address field that includes CA. So you can imagine how flexible this could be. And back to Ronan's demo before, think of all the operational tasks that you could potentially encapsulate as tools, because this is the stuff that you know in your head. You've got an issue with your application, what do? I need to check DNS, it's always DNS. You've then got to maybe check the network logs, you've got to check a load balancer, you've got to check if there are any errors in the Lambda function, or you've got to check this. And that's sort of all institutional knowledge you actually have in order to solve your problems. Well, imagine if you could encapsulate them all in tools, because you probably have a DNS checker, or you have something that pulls logs, or you have something that checks Lambda logs. So you've got, in a way, these tools built into your organization, and you can encapsulate your existing tool with a little bit of MCP magic and create a tool that an agent can go, well, you know what? When you need to fix an issue, generally, I'm going to try this. I'm going to do a DNS request. If the DNS request fails, what can it do? And instead of having to have this complex mapping path for your operational things, maybe your LLM can help you and sort of use an agentic way. And maybe it's not going to do everything for you, but it could at least start and help you along with some of your troubleshooting. So I talked about running AI-generated code. Now, I don't know about your code. I'm sure your code is type safe. It has all the security and everything built in. No security issues with your code. My code's not the same. My code is probably terrible. And that's my code that I've maybe written by hand. Would anybody trust the code generated by an LLM? Who knows what the LLM is going to say? Maybe there are some weird sort of hackers that have gone in and the model's been trained on some dodgy data. Who knows? But certainly, this is a silly example to think of untrusted code. But think of SaaS companies or many kind of companies who want to get information from the LLMs and then want it to run customer code. Maybe it's going to be a query, maybe it's just going to be a SQL query or this kind of thing. You can't trust that. Well, I know of a service at AWS that is actually really good at running code securely. And that's Lambda, because why? It runs in a secure micro VM environment. By default, it's got access to absolutely nothing else. So you could run customer code, and maybe you will never give it access to anything in your VPC, no access to any databases, maybe only access to the internet, or maybe only access to one kind of thing. You've got this way to build different Lambda functions with different functionality, and so you could run this code securely. So we're going to use Amazon Q again. I didn't think I turned on the trust kind of thing, so let's see what it does. I've got the MCP servers loaded, and I just want to say, well, also, list the tool names in the description. So this is also, I'm asking the LLM, what do you know of the tools that it's going to run? Obviously needs to think, and then goes, here are the tools available. And here you can see those names and those descriptions and the schema. So this is what the LLM knows. Going back to that explanation earlier, knows exactly what it's going to run. So this is the intelligence for the prompt that is basically sending to the LLM when doing the tools. So why don't we write some Python code? So I think I needed to just change the security. Maybe I'm going to do that. But then I'm going to think, well, why don't I like some things about prime numbers? So I'm going to calculate the number of prime numbers between 1 and 10, 1 and so on up to 1 million. So this realizes you want to run some code, you want to run a function. Well, let me create a Python script that efficiently counts prime numbers. So this is actually going to create some Python code. I'm just going to accept it. And this is, input script. This is literally Python code. It's generated directly. What it's going to do is it's going to upload that to Lambda, run it, come back, and then give me a nice sort of pretty information. So that's AI-generated code. Isn't that cool? It's just done that. It's written code for me on my behalf and run it really well. Okay, I'm going to do the test thing. Let's make it a bit more local. I want to parse the Serverless Days Belfast agenda website and suggest 2 talks which are going to be useful to listen to. And I appreciate you're here at the end of the day, so you listen to all the talks, so this is a bit behind the scenes. Find 2 interesting talks. So what is this going to do? Ask the LLM, I need to do something. I'm going to use MCP Lambda again, and I'm going to build a scraping tool. Very different from prime numbers. Very different from what I've done before. But here it goes. It's going to build all these kind of things, and it's actually got an error. Oh, I've got an error passing the web page. So it goes, I actually need to install some modules to be able to actually pass the website. So why don't I generate a new Python function with some dependencies that it's going to do? And this way is cool because it's actually built to install the request library and the amazingly mentioned beautiful soup library to be able to pass a website. You can see it knows the dependencies, so it's installed requests, installed beautiful soup, built up a whole Lambda function, installed the dependencies and run the code and actually parse the Serverless Days Belfast website. If it errored, it would try another way, keep going until it could do the website. So here it goes. Based on the agenda, we've got Sijon, an idea how Serverless is serving retail, and I promise you this wasn't a fix. I ran this about 10 times and it was 2 different ones every time, and then when I did the recording, I was like, yes! So I promise you we didn't take the gen out. But you can see what this has done. I mean, this is crazy. It's actually written a Python function from scratch, uploaded it to the model, run it all securely, parsed the website, and then send it back to the LLM and said, give me some more information. So, I mean, the nice thing is this, this talk seems especially timely and forward-looking. Oh, thank you very much. That's very kind of you. You haven't even seen the talk. So yeah. Also mentions Patrick DeBar's Keynote and Simon Wardley's Keynote. So maybe it just picks up the term Keynote and goes, oh, they must be important. But that's it. So here you go. You've got the combination of using a tool. I've written arbitrary Python code in this example, could have been anything, and then it's just going to do something pretty with the LLM. So obviously, this is all a fast emerging space. And it is exciting, but it's a bit crazy and a bit weird. And I mean, certainly the buzzword bingo is going insane with Gen AI. And you want to sort of have one foot on the hype train, but not keep so mad. So it's exciting. And there are lots of ways to do agentic stuff. This is MCP, but there are many other ways. You have Amazon Bedrock agents. You've got so many different companies with different ways of running managed agents. And maybe in big organizations, there are different ways of doing things. And that's all cool. This is just MCP, which is a different way of doing it as well. Obviously, rapidly evolving. There was probably a new spec that came out while we were doing this talk. As Ronan says, by the time this is on YouTube, people are going to be throwing tomatoes at the screen, or in Ireland, maybe potatoes, and saying, your talk is completely out of date, this is useless. That's what it is. It's part of looking at these kind of things. And of course, do you like the taste of Kool-Aid? Because all companies, you saw the list of MCP servers, everyone's throwing MCP down everyone's throat. And of course, there is a super, hopefully positive and amazing future of this, but I think there's a lot of Kool-Aid we need to drink in that process until we work out the actual cool stuff that's going to do. So a bit more practical things. Remote MCPs are a bit more complex. You are running a server in a Lambda function, for example. Authorization is very basic. Some of the security is, just download a tool, run that locally. You don't need to care where that's come from. It's a Docker container. It's fine. It's Python, whatever. Off you go. Like, seriously, would you, really do that? Maybe yes, maybe no. So there's a curation process, obviously, for looking at your tools. And of course, at scale in your organization, are you going to have Python installed and Node installed and Java installed on all your clients and everything? You can imagine that would be a nightmare. Or even having, mandating for your whole customer service organization. No, you have to have Docker installed on all their workstations because that's how the tools are going to run. So, I mean, you can imagine that there is a sort of chaotic future which we're going to have to navigate and see how this works. But I hope this sort of... the last thing is, AWS is very actively involved in actually contributing to the MCP protocol. We've got people with different languages and different kind of things, improving MCP itself, not just for serverless and containers and Lambda and this kind of thing, but looking at the spec and involving different kind of things. Because MCP is just one way to do this, but there are other different agentic ways, and each of them have got sort of really pros and cons. And the industry is trying to sort of push the pros into the MCP thing, and AWS has got a sort of front row seat with a great partnership with Anthropic to make that happen. So maybe a bit of a rallying call. It's the end of the day. I know Ronan and I are distinctly aware we are between you and beers and everyone's sitting in the sun. But just, as you've been thinking about this talk, it'd be interesting to think about sort of, what kind of MCP servers are you using? What could you connect to? What would be easy to grab information from, grab your architecture diagram and build something, or connect with Stripe or GitHub or, some CI/CD pipeline and just be able to ask questions and get it to do things. And then if you're brave and adventurous, well, the whole new world is up for grabs. What kind of MCP servers could you think of building? What kind of tools in your company, or what kind of tools do you use that you could expose as MCP servers for other people to consume? So Ronan said there are 2 QR codes over here as well. We've got some serverless MCP examples. Of course, that's the first one you should try because they're serverless, and that means they must be better. But also, this is a general AWS MCP servers where the documentation one and many others are, and lots of people are contributing to that as well. So a fun and exciting place. And thank you so much for joining us here to wrap up Serverless Days. Ronan and I are super proud to be here. Hope you've had a good day. Thanks so much to the organizers for putting on such a great day. And yeah, run MCP. Thank you very much.